So I want to talk a little bit about what the formula may look like compared to what it does. So you just saw that boric acid, it didn't change from the reading we're getting for wastewater or when I'm washing it with distilled water. So that means it's probably not really an acid. They used to wash people's eyes out with boric acid, so I'm very glad that it doesn't actually act as an acid. Now on the phosphoric acid, if you'll notice, I gave you some equations of how different substances dissociate in water on page 3 of the lab. Now, sodium chloride dissociates into 2 ions, calcium chloride dissociates into 3 ions, and aluminum chloride dissociates into 4 ions. Now, for phosphoric acid, you're going to compare the value that the reading you got for phosphoric acid and see, does it act like it has 2 ions? Does the reading show it acts like 3 ions? Or does the reading show it acts like 4 ions? You need to decide, and then you need to pick one of these 3 equations right here, the phosphoric acid equations. You're going to pick one of them that you think shows how it behaves the best, not by how the formula is written, but by the actual reading we get, by the experimental value. And then for acetic acid, hydrochloric acid, and boric acid, you're going to use one of three ways to show whether it's weak or strong. If you think it's weak, it gets a 2-headed arrow, like this one right here. That shows that it's a weak acid, that even though some of it dissociates, some of it goes back together just as quickly. If you think one of these acids is a strong acid, you put a single-headed arrow like this. This shows that it mostly dissociates and it doesn't come back together, so it's a strong acid. And then there's a possibility that there's no dissociation at all. And the way we show that, the symbol we use to show that, is we use a forward arrow with an X through it to show that nothing is happening at all. So for question number 4, you're going to write an equation for each of the group B compounds, and you're going to either use a forward arrow, a 2-headed arrow, or write no reaction if it doesn't seem to conduct electricity at all. And for question 5, what it's asking is, does the 3 in H3PO4 and H3BO3, does the 3 seem to result in additional ions in solution? Now, if the 3 resulted in additional ions, these would act like they have 4 ions each, and they would be comparable to AlCl3. So look at the values for these guys, and then look at the values for the other salts, and see what you think about whether that 3 gives you extra ions or not. Now we're going to test some group C solutions. And the first one we're going to test is distilled water. Distilled water should be almost pure water. And look at that. It gives us a very steady reading of 99. Now, since we don't have any way to calibrate this probe, we're going to calibrate it with distilled water. And the way you're going to do that is you're going to take the reading for distilled water, 99, and you're going to subtract it from every other reading. So that distilled water actually reads 0, boric acid reads 0, and you're going to subtract 99 from all of the other conductivities, and that's going to be your adjusted conductivity column. And that's going to be the column you use to answer questions. The next chemical we're testing is tap water. And is tap water a chemical? You betcha. Everything's a chemical. Oh boy, tap water doesn't look the same as distilled water. One of your questions is to answer why you think that is. What do we put in tap water to make it drinkable? The hint is it kills germs. The next chemical we're going to be testing is methanol. This is also known as wood alcohol. Looks like it's giving us a 99. Does that mean the probe is broken? No, that means that this is a molecular compound that does not break apart in water and does not produce ions. And finally, the last chemical on our list to test is ethanol. Ethanol is your standard drinking alcohol. The kind that makes you a little bit sick, gives you a hangover, and will poison you in large amounts, but as long as you're careful with how much you drink, it's not too deadly. And that's the reading for ethanol. So that is also a molecular compound.